Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the quotient rule for derivatives. So as per the problem, the graph of f at x, which is equal to ax plus b over x minus 1 times x minus 4, has a horizontal tangent line at 2, negative 1. And we have to find the values of a and b. So a and b are the terms in the numerator and we have to find their value. Now we are given that this function has a horizontal tangent line at 2, negative 1. That means the slope of the tangent line at 2, negative 1 is equal to 0. So the first step here is to find the derivative of the given function, which represents the slope of the tangent line. Now, since the given function is a rational function, we'll use the quotient rule to find its derivative. Now, in this function, as you can see, the denominator is made up of two factors being multiplied to each other. So before we use the quotient rule to find the derivative, we should distribute the terms in these factors to get a single expression. So the first step is to rewrite this function and distribute the terms in the denominator. So we get ax plus b in the numerator, so that stays the same, and in the denominator we use the FOIL method. So we multiply x by x, and x by negative 4, then negative 1 by x, and then negative 1 by negative 4. So in the denominator we get x squared minus 4x minus 1x plus 4. Now we can combine like terms in the denominator. So we get f at x equals ax plus b over, so in the denominator, so minus 4x and minus 1x can be combined into minus 5x and then plus 4. Now we can find the derivative of this function using the quotient rule. So the slope of the tangent m is equal to prime of f at x, which is equal to, so as per the quotient rule, we start with the derivative of the numerator, which is a times the denominator minus the numerator times the derivative of the denominator, which will be 2x minus 5 over the square of the denominator. Now we can simplify this expression by simplifying the numerator. So we get m equals, so in the numerator we can distribute the a into the parentheses. So we get a x squared minus a or minus 5ax and then plus 4a. Now in the second part, we can do the distribution using the FOIL method. So we multiply ax by 2x, then ax by negative 5, then b by 2x, then b by negative 5. So we get 2ax squared and then minus 5ax and then plus 2bx and then minus 5b over the denominator. So x squared minus 5x plus 4 squared. Now we can simplify this further. So we get m equals, So in the numerator, we can distribute the negative sign into the parentheses, and that will make the sign of each term in the parentheses flip. So the sign of each term in the parentheses will change. So we get m equals, so ax squared minus 5ax plus 4a, then minus 2ax squared plus 5ax, and then minus 2bx, and then plus 5b over x squared minus 5x plus 4 squared. Now we can simplify the terms in the numerator by combining like terms. So negative 5ax and positive 5ax will cancel each other out. Now we are given that the tangent line is horizontal, so that means the slope is equal to 0 and the point is 2, negative 1. So we should sub in x as 2 in this expression. So we get a times 2 squared plus 4a, then minus 2a times 2 squared, then minus 2b times 2, then plus 5b over, then 2 squared minus 5 times 2 plus 4 squared. Now we can simplify the terms in the numerator. So we get 4a plus 4a, and then 2 square is 4 and 4 times 2 is 8, then minus 8a and minus 4b plus 5b over, and in the denominator we get 4 minus 10 plus 4 squared. So this can be simplified. Now in the numerator, so 4a and negative 8a cancel each other out, and minus 4b and 5b can be combined to just b. And in the denominator, the 4 minus 10 plus 4 is equal to negative 2, and negative 2 square is equal to 4. Now we can solve for b by cross multiplying 4, so we get 0 equals b. So this is the value of b. Now we have to find the value of a. Now we are given that the tangent line is horizontal at this point 2, negative 1. That means this point 2, negative 1 also lies on the function f at x. So we should sub in x as 2 and function value as negative 1 and then solve for a. So I'll use a different color for that. So we sub in f at x as negative 1. So we get negative 1 equals a times 2 plus 0, because b is equal to 0, over 2 minus 1 times 2 minus 4. So we have to solve this equation to find the value of a. So we can go on this side. So we get negative 1 equals 2a in the numerator, because addition with 0 doesn't change anything, over 1 times negative 2. So we get negative 1 equals 2a over negative 2. Now we can cross multiply the negative 2. So we get 2 equals 2a, because negative 1 times negative 2 is equal to positive 2. And now we can isolate a by dividing both sides by 2. So the 2's on the right side will cancel each other out. So 2 divided by 2 is equal to 1. So that means the value of a is equal to 1. So these are the steps you have to keep in mind to solve a problem like this one. So it's very important to understand that we have to first find the slope of the function and then sub in the slope as 0 and x as 2 because that's the point at which the tangent line touches the given function. And from that we got b equals 0. And then we sub in that point in the given function to find the a value, which is equal to 1. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.